Hi, this is the second part, and this one is extremely important. Now, here we are talking about Coulomb's law. Why we use Coulomb's law? We are using Coulomb's law to find what is the electrostatic force acting on a charge. Now, this charge might be affected by one charge or two charges or three charges. Based on the arrangement that you are going to have, you are going to calculate the electrostatic force based on 1 to 1, and then you're going to move to the next one and then to the third one, and then you're going to add them as vectors. Now the magnitude here for a force between any two charges, it is equal to a constant, we call it K electric, the magnitude of Q1, which is the first charge, the magnitude of the second charge divided by R squared. Now the force, it is measured in newtons. Its direction can be determined based on if they are both positives or both negatives, they're gonna repel each other. If they are positive and negative, then they're gonna attract each other. K electric, it is the electric constant, and its value, it's 8.99 10 to the 9 in Newton meters squared divided by coulombs squared. The absolute value of Q1, it is the magnitude of charge 1 in coulombs. The absolute value of Q2, it is the magnitude of charge 2 in coulombs as well. R, it is the distance between the charges, and here we are considering the charges to be point charges, then they don't have a size. Fundamentals of Coulomb's law, it is talking about that the force is directly proportional with the product of Q1 times Q2. Then if you double Q1, just Q1, you're gonna get 2F. If you double Q2, you're gonna get 2F. But if you double both, you're gonna get 4 times F. If you double R, now R, it's a different story. Increase in R will make F decrease. And if we double R, we're gonna get 1/4 of the force. And if we are tripling the force, tripling the distance between the two charges, the force will drop to 1/9. If we are making it 4 times its initial value, is going to be F over 16. These laws here that obey this rule, we call them inverse square law, because you can see in the equation that it is here squared. Okay, therefore, F is going to be K electric Q1 times Q2, and then 2R squared, and then therefore when you square R, you square also the 2, then it's going to be 1/4 of the original force. One more thing that needs here to be mentioned, any charge in nature has to do with the electronic charge, then it is N as a number of integer, which is 1, 2, or 3, or 4, or 5, times the electronic charge, which is 1.6 10 to the negative 19 coulombs. Now, this is just an application of the last point. If 1.80 10 to the 20 electrons move through a pocket calculator during a full day's operation, how many coulombs of charge moved through it? Okay, then N, it is here, 1.80 10 to the 20 electrons, and Q, it is N times E, which is 1.80 times 10 to the 20. This is times negative 1.6 10 to the 19 coulomb, and therefore is going to be negative 28.8 coulombs. Now, one more thing we need to know is, if the charge is positive, you're going to say it's a plus. That's it, okay, or a proton. Now, a 50-gram ball of copper has a net charge of 2 microcoulomb. What fraction of the copper's electrons has been removed? Okay, this is really, remember I was talking about the discussion that if we add electrons, this is going to be negative. If we remove electrons, they are going to be positives. Okay, then here we have the mass, and we need to convert this into kilograms. And charge, it is plus 2, and again have it in coulombs, 10 to the negative 6. We need to find first what is the number of moles. Now, the number of moles equals the mass divided by the atomic mass of copper, which was provided as 63.5. Then here we were able to calculate what is really the number of moles. Now, MP, it is the number of protons, is going to be N, the number of moles, times Na, which is Avogadro's number, times 29, which we got from here. Okay, protons per atom. Okay, then here we can find the number of electrons by calculating, which is the number of moles divided by this is the number of moles, the whole thing. This is Avogadro's number. This is 29 protons per atom. Then this is going to give us what is really the number of protons. A neutral atom, same number of electrons and protons. For this atom, we have then 1.375 10 to the 25, because the number of electrons equals the number of neutrons. The number of electrons equals the number of protons. Since it has a net charge of 2 10 to the negative 6, we need to find how many electrons have been removed, and this is going to be the Q net divided by 1 electronic charge, and that is going to be 1.25 10 to the 13 electrons. And we can actually calculate what is Ne removed divided by Ne initially, and we will find that is going to be, this is the ratio, 9.09 10 to the negative 13. This question is very interesting. 2-point charges are brought closer, increasing the force between them by a factor of 25. By what factor was their separation decreased? And then initially, we will put Q1, Q2, and R1, and we're going to say this is F1. Now, F2 that we are talking about, it is 25 times F1. Therefore, I'm going to here multiply this here by 25, and this is going to be F2, where I just substituted instead of R1, R2 squared. And therefore, I will create a relation between the two radii. Okay, and then in order to get what is R2 with respect to R1, I'm going to take the square roots, and then R2 equal 1 over 5 R1. I will continue with more problems. Thank you.